Hello students, I come to this topic in physics, scalars and vectors. And this is one of the introductory topics in physics, since physics also studies physical quantities. A knowledge of this topic, scalar and vector quantities, will enhance your general understanding of physics. Physical quantities are the physical properties of an object of matter that can be measured by an instrument or by our sense. So, of course, you know that matter have some properties. The properties that you can measure, like length, like time, like mass, like speed. These properties of matter, they are called physical quantities in physics. Let's say you have a table in front of you. Now think about the length of this table. You can measure the length of this table using a tape or using a meter rule. Now the length of the table, being a measurable entity, quantity, is regarded as a physical quantity. So an example, length. Then the mass of a body. If I ask you, tell me how much you weigh, your mass, you need an instrument. And even if you have two objects in front of you, you can by experience know which one is heavier. So that object, the mass of a body, is the quantity of matter that body has. So just by inspection, you'll be able to tell that this object, this body, is heavier than the other. So that's why the mass of a body is a quantity in physics. You have a textbook in front of you. That textbook occupies some space. The space occupied by an object is its volume. So volume is another measurable entity. So it's a physical quantity. Now these quantities we study in physics can divide them into two, scalars and vector. A scalar quantity is a quantity that has only magnitude, its quantity, but no direction. So it's a quantity that has only magnitude. You can describe, you can represent, you can define that quantity completely by stating only its magnitude. Magnitude means size. Magnitude, another word for magnitude is a amount, size, value. For instance, you can have a mass of 50 kilograms. So you can see that the quantity here is 50. That shows that a scalar quantity requires just the magnitude, which is a size, and a unit to describe it completely. We have other examples. We have volume, we have density, work done, speed, energy, power, area, time or frequency, temperature, distance. Distance is a scalar quantity. Length, breadth, width, height, and so on. They are all scalar quantities. How about potential difference? A scalar quantity. Resistance, charge, pressure, and current. What is pressure? A scalar quantity. Pressure is defined as a ratio of force to the area of the surface in which the force is acting. Now, in a liquid, pressure acts in different directions and they act equally in all directions. So pressure at a particular level act equally in all directions. So a vector quantity should have a specific action or a specific direction of action. So since pressure acts in many directions, we put that as a scalar quantity. We classify it under scalar quantities. How about current? We expect current to be a vector. Current flows in a particular direction in especially direct currents in a circuit. But in some cases, when we start talking about manipulating current. It doesn't follow vector operation. It follows scalar. It follows algebraic operations when we are dealing with current. Okay, so we see that scalar quantities are quantities that require only magnitude, or the quantities that are represented completely by stating their magnitude and the direction. We can apply the rules of algebra in dealing with scalar quantities, such as addition. You can add two scalar quantities together. Let's say you run for a time of 10 seconds from point A to point B, and then you run from point B to point C in another time of 20 seconds. You can add them together, which means you have run for a total time of 30 seconds. So the rule of algebra, addition, subtraction, multiplication, and division, all these apply to scalar quantities because no direction is needed here. Okay, so a scalar quantity can change only when you change its magnitude. So it changes when only its magnitude, the size, changes. Let's say you have the speed of a body is initially given as 20 meters per second, and then after a while it changes to 30. So a change in magnitude, a change in size is enough to change a scalar quantity. Okay, so but what's a vector quantity? A vector quantity is a quantity that has both magnitude, and direction. That's a vector quantity. So which means a vector quantity can take a magnitude, a unit, and a direction. An example is a force of 50 Newton acting in a direction due east. And this is a vector quantity force. The magnitude is size is 50. The unit is in Newton. And the direction is due east. So the other directions we can use to represent direction a vector quantity is acting, like north, like west, like south, and so on. A vector quantity must be specified completely by stating both its magnitude and its direction. If only magnitude is given, then that vector is not represented completely. It's as good as calling it a scalar quantity. So if I must call this a vector quantity, I must look out for its magnitude, which has a size, which is also equal to a size and a unit, and a direction in which the vector is acting. We have a number of examples of vector quantities. Examples include we have displacement is a vector because displacement is distance covered in a stated direction. Velocity is a vector, the rate of change of displacement. Acceleration is a vector, velocity change over time. Force is a vector because that's the direction of action. Impulse, the impulse of a force is the product of the force and the time in which the force acts. Is also a vector. Momentum, moment and torque, electric, magnetic, and gravitational fields or field strength. They are all vector quantities. How about angular displacement, angular velocity, and angular acceleration? These are all vector quantities. Now, unlike scalar quantities, it is not that easy to manipulate, to compute, to add two vectors quantities just like we did for scalar quantities, because you must take into account the direction and the magnitude when you are computing vectors, when you are combining two or more vectors to have a result. And the result of combining two vectors is called the resultant vector. So which means we need some other means of combining two vectors I will call that a geometric method, a vectorial method of combining two vectors. The next video I will show you how to compute two or more vector quantities.